exercise 1712 in your book. It's on page 742. Okay? But you can also just jot down a few notes. I'm going to get the problem started, and then I'm going to let you finish it using the sample exercise. Okay? Now, I'm going to the problem talks about calcium fluoride. Okay? I want us first to remind ourselves what we've been doing the last 2 nights, because this will help you on the quiz. If I had asked you what is the molar solubility of calcium fluoride in water, or usually we don't even say in water, that's kind of implied, right? I have to give you a KSP, in this case 3.9 times 10 to the negative 11, okay? We start this off simply by considering calcium fluoride is a pretty insoluble compound, but if it dissolves, you'll get a little bit of calcium ion, and you'll get a little bit of fluoride ion in a 1-to-2 ratio. Everybody good with that? Remember, these are aqueous. All right. Now, I want you to think about it from kind of an icebox perspective. Initially, we might have some of this, but we have 0 of this and 0 of this before we actually stick the solid in the water. It's just pure water. Okay? Once we stick this in the water, isn't this going to start dissolving? And however much dissolves, you could call it X if you want to, then you'll have 1X of this and 2X of this, right? So once it gets to the point that it's at equilibrium, we'll have some minus X. Not that this matters, because do we put solids?
No.
No. Okay, so we really don't need to worry about that, but this is going to be 0 plus X, which is X, and 0 plus 2X, which is 2X. And then we do what we've been doing. We have our KSP expression. That would be equal to calcium to the first, fluoride to the what?
Second.
To the second. We're simply going to plug in an X for calcium, raise it to the first, a 2X for fluoride, raise it to the second, and set that equal to 3.9 times 10 to the negative 11. When we simplify this, 2x in parentheses squared is 4x squared times x is 4x cubed. So we'll take our 3.9 times 10 to the negative 11, divide through by 4, then take the cubed root, and I get 2.1 times 10 to the negative 4. What's the unit on this? It represented this bracket. Molarity. That is your molar solubility. Okay? Yes, Amina?
Why is it negative x? In the CAF2?
Here?
Yeah.
Well, you took some and some of it dissolved. So it went from this to this. But it doesn't really matter because, we don't even plug that in. Right? Okay. All right. So that's what we've been doing. Okay? What you're going to do tonight looks very similar, but there's one change. I'm going to ask you, what is the molar solubility of calcium fluoride in a 0.01 molar solution of sodium fluoride? Okay, so now instead of starting with pure water where there's 0 fluoride present, what are we starting with?
Some fluoride present.
Some fluoride present. That's right. So we're going to do the same thing we did before. I want you to see how similar this is, and then see the places where it's different. So we're still going to draw our ice box, okay? And then here, initially, we don't really even worry about this. You'll see the sample exercise doesn't even worry about it. Here, you start out with 0, but here we have 0.01. Do you see that?
Yeah.
Because let me ask you this. What do you know about sodium fluoride? Is it soluble? Yeah, it's completely soluble. So this only exists as Na plus and F minus. Do we have to worry about the Na plus? No, spectator. So our concentration of fluoride is 0.01. That's what you plug in. You don't multiply it by 2. Okay? You are plugging in your fluoride concentration. Now, however much of this dissolves, you will get X of this and 2X of this. Do you see how that's just like we did before?
Yeah.
So the only difference is instead of starting with 0, we have some. This is called the common ion effect. We have one of those ions already in there. Now let me ask you this question. You're welcome to look. You're welcome to look. Are we going to be able to dissolve the same amount of calcium fluoride as before?
No.
No. You already have, remember guys, you're allowed to have your concentration of calcium and your concentration of fluoride that equals this, 3.9 times 10 to the negative 11. You can't have any more than that. It's saturated. You can't have any more. So if you already have 0.01, we're not going to be able to dissolve quite so much.
Yeah.
Does everybody get that? Okay. So now in equilibrium, we're going to have 0 plus X, or X. Now this is going to look different. What's this going to look like? 0.01 plus 2X. So now let's throw that into our KSP expression. Ca plus 2 to the first, F minus to the second. So this is going to be X times 0.01 plus 2X squared. And that's going to be equal to 3.9 times 10 to the negative 11. Can you guys say gross math?
Yeah.
Yeah, that's looking complicated, isn't it? I want to let you in on a secret, okay? Was this number a big number?
No.
Not so much. And is this going to be bigger or smaller than that? Even smaller. So let me ask you this, guys. If I have 0.01 and I add to that 0.0000 something, it's not really going to matter. Aren't I basically going to still have 0.01?
Yeah.
Here is the deal. If you have things that have very low Ks, like KSPs, your X is such a small number anyway that when you compare it to a number, it's negligible. When you compare it to 0, you have to count it. Anything compared to 0 is significant. So what's cool is when we work our problem, we can just ignore it. Now is the math easy to solve? Yeah, in fact, it's even easier than before. We square the number. We don't even have to take a square root in here. And you'll solve it from here and get your X. And that will be your molar solubility. Okay? So, they look very similar in that you do ice boxes. We write reactions. We write KSP. The only difference is instead of starting with 2 zeros, you have a number. And you get your value, but then you're going to ignore it. Okay? Tonight, all the problems I've given you, you're allowed to ignore. The number will be so small that it's negligible. We'll talk later about when you can't ignore and what you do. Okay? But I'm going to stop the problem here because I think from here on it's algebra, and the book actually walks you through. Okay? All right. Great. Thank you, Kelly.